Hello students. So today I'm going to solve the mid-semester exam problems, and I would also tell whether this was a part of the tutorial problem, whether I covered during the live session, or whether I discussed in particular about something during the lectures. Yeah, and this is also to specify or to actually stress that it's important that you solve the tutorial problems. It's important that you attend the live sessions and also see the lecture videos regularly. Yeah? So just solving tutorial problem will actually not going to help much, so it may also help if you do sincerely, okay, but there may be something that I may talk about during the live sessions. So all those things you have to listen carefully, and hence I recommend attending all the live sessions and watching all the lecture videos. Okay, so starting with I will start from the chapter 7 of the ebook, and from there I will go backwards. So chapter 7 problems. Okay, now since all students get same problems but different data in that, okay, so hence I cannot just solve basically just based on some like a mass equal to 5 kg. Somebody will get 3 kg, somebody will get 3.9 kg, and so on. Hence I will solve with just m for mass. That way you can put your values, you can check also. Yeah, that's one thing. Second thing is numbering is also not the same. All the students will give different question number for the same problem. For multiple choice also, the choices ABCD all they are also basically not in order. Somebody gets option A, the other, for others it could be option B or C or something like that. Hence I'm going to solve this brief general purpose way, so that you can put those values. I will find out the answer. So chapter 7 we had a problem on the string under tension. So let us say this is like this one, this is under tension like this. Yeah, okay, so now I asked two things. So one thing I asked, what is the wave velocity? Okay, so for wave velocity, if you have studied, you have seen lecture video or studied the textbook, or there was a particular there was one tutorial problem also that I gave on the finding out the wave velocity for this one. So it is not just one place, many places the same thing, same problem appear, either in lecture video or tutorial or during the actually I solved the tutorial also. The last video was the solving tutorial only. So what I gave was, I gave the tension here, okay, and the value I gave in Newton. Then material property. So material property I gave say rho I gave. Yeah, so rho again it would be kg per meter cube, kg meter cube, and give the diameter d also. Okay, so diameter would be in millimeter or centimeter, whatever. Okay, so if that is the case, so accordingly how do you solve it? Remember this rho, specifically in the one of the lecture videos I said this rho you cannot use it. This is rho v, that is in kg per meter cube. What you need for wave velocity is c equal to root t over rho, but this rho is in kg per meter. Okay, so hence you have to change it. How will you change it? Okay, so kg per meter you have to multiply by area. So let us say this is called rho L. So rho L equal to A times rho V, right? So what you get is equal to T over A rho V is equal to root T over pi over 4 D square rho V. So this is this will give you the velocity of the wave, okay? And if you watch the lecture video, specifically I said that you have to be careful with that, you know. So this is a kg per meter, it has to be not kg per meter cube, but still not everybody got this right. Yeah. Second part, this is the one part where you have to find out the velocity. The second part will be the find out the natural frequency of that one. Yeah, natural frequency, again, the finally if you see the lecture video last one where I solved the tutorial problem, so if you see that finally what you have, so this will be sine alpha x, which satisfies the boundary condition. So has to be 0. I mean the qx, we say px times qx, so the px automatically is of the sine alpha x form, because this at x equal to 0, the y equal to 0, and hence this is only satisfied. So this is the one which will be the 0 at x equal to 0 and x equal to L, and hence sine Lx has to be 0, and which is possible, sorry, alpha L. Okay, alpha L equal to 0, and which is only possible when alpha equal to n times pi, and hence alpha equal to n pi over L. So this is alpha. In the lecture videos, you will see that omega n is equal to alpha times c, basically simply alpha times c, or alpha times t over rho L is the how the natural frequency is n pi over L root and you have 4t over pi d square over rho v. Rho v means the density of the material. Yeah, so rho v is the material density, and hence you have to give this one in kg per meter cube one. Okay, so this is what the equation will be. Now fundamental frequency, when fundamental means n equal to 1 is the fundamental, the minimum, right? This is the fundamental. Yeah, and hence you get omega 1 is the answer over pi over L root 4t over pi d square rho v will be the answer, which will be the frequency. Again, I specifically said you have to give in radian per second. This omega is radian per second, so it gives you. Now the next question from the same chapter, from chapter 7 only, is on the longitudinal waves through the bar, right? So fixed bar. So this is fixing at one end. So this is at x equal to 0 it fix, at L x equal to L it is free. Again, equations will be of the same form, and finally since at x equal to 0, and hence the y has to satisfy this boundary condition, hence sine alpha x is the form of y. So y contains equal to this multiply by a function of some function of time, it will be there, right? It will be something like this. Okay, now this here alpha x, if you put x equal to 0, it will be 0, but here it is free. Free means what? Free means here force equal to 0, right? So force equal to 0. Force equal to 0. This also I solved in the tutorial problem in the last video actually, and one of the problems given to you was also from the similar problem as a tutorial, right? So okay, so this is given like this one. Now the that really means f equal to 0 equal to, that really means sigma times area equal to 0. Yeah, sigma is E, right? E times a times dy over dx. So not y but u the displacement, right? So this is u. So du over dx equal to 0 at x equal to L, and hence du over dx, that really means du over dx equal to 0 at x equal to L. That really means du over dx nothing becomes actually the cos. So cos alpha x equal to 0, right? And hence it will give you alpha times L equal to, you get pi over 2 n plus pi over 2, right? Sorry. Okay. So n plus half times pi. So this is the this will be the value of alpha L, and hence alpha will be equal to this n plus half times pi over L, yeah, and omega becomes, omega n will be same as earlier we got that for this one, it is E over rho. Now in the lecture video or in the tutorial, in the one of the videos, I specifically said here this will be of the form of, this will be Newton per meter cube. This is material property. Here it will be E, not G. Even if I gave you, the problem will have E also, G also, and rho also. Rho material property comes from here, yeah, and this may be some diameter as well, yeah. So but finally what is the relevant here is E and rho, right? Rho where Newton per meter cube, and here it is Newton per meter square. This is what two things will be relevant for the C part. So omega n will be this C multiplied by alpha, right? So what you get, alpha n, alpha fundamental frequency will be alpha omega 1 equal to E over rho v times this becomes 1 plus half, because n equal to 1, times pi over L. So L is given, E is given, this given, you get find out what is the value of this one. This is okay. So this is the, say, third question from this chapter, and this you found out the fundamental frequency. Fourth one, we found out the wave speed. Wave speed is nothing, as I said here, it is simply E over rho v. Rho v meaning that this is volume density, yeah, mass per unit volume, yeah. So this was given for the material, this is also given, hence you can directly find out from there. Okay, again this is not something which was not covered during the lecture, also it was covered, during the tutorial it was covered, yeah. So then I solved the tutorial problem, there also I solved this one. Now the fifth problem from the same chapter was about the torsional vibration, right? So same setup, fixed at here and done free at here, and I asked you what is the frequency for the vibration, torsional vibration. Again, this is similar to, exactly similar to the axial one. Okay, so you get the exactly similar boundary condition. So it is free here and this is fixed here. So omega n you get as n plus 1 over 2 times pi. So n plus 1 over 2 times pi is the alpha equal to alpha divided by L, and hence omega n equal to alpha n multiplied by G, here G over rho, not E but G will come now here, right? So okay, so here this one is the shear modulus. Even if the question had E given, but E was not relevant here, so you have to just choose Z. So, and Z means shear modulus, and this is rho V, means it will be Newton per meter cube 1. Yeah, so you have to use that. Yeah, so okay, so omega n becomes equal to n plus half pi over L multiplied by G over rho, and omega 1 is the fundamental, was the minimum one. The fundamental will be n equal to 0. Yeah. Okay, in a previous question also, the fundamental is n equal to 0, not n equal to 1. Okay, so please replace that. Okay, so whatever value you get here, the same will be applicable there. So I made a mistake. So instead of saying n equal to 0, n equal to 1, will be n equal to 0. So omega 1 equal to half pi over L root G over rho will be the answer. This answer will be for both, for this also and for the previous problem we are talking about, for the axial load as well. Yeah, for this also. If the longitudinal, for longitudinal also you get the same thing. So this is what the fundamental frequency you get. Yeah. Okay, so for longitudinal one, for this one, the correction to correction of problem number 3 that we discussed from chapter 7. So I said omega n will be equal to n plus half pi over L, then you have E over rho, that is for bar which is fixed at 1 end, and longitudinal wave we are talking about. Okay, so fundamental frequency is omega naught, because you put n equal to 0 here. This is valid for n equal to 0, 1, 2, 3 and so on. So omega naught should be the fundamental one. Hence your solution will be pi over 2L and times E over rho. So this is this one is the right answer. Omega you get, this is the fundamental one. Okay, so this is the right answer. Okay, so these are the correction. The last problem from this chapter, chapter 7, is about which kind of problems have hyperbolic sine and hyperbolic cos term. Okay, so this again is if you see the lecture videos, you will immediately recognize. I explain again and again why sine hyperbolic comes and cos hyperbolic comes on those things, right? So this comes when you have beam bending. Yeah. So for example, this is a beam fixed at one end or fixed at both the ends, and this is bending problem. If it has bending, this will come. Yeah. So this is again covered a lot in the lectures. Still, many students could not get it. Now chapter 5 and 6. Okay, so multi-degree of freedom system. Okay, so one problem you would see there which says that mass is of the form something like M11, 0, 0, M11 is mass, is a big mass like this one, and K is something like K11 and K12, K12, both will be are same given. This and this diagonal are same. So this is what is given. This and this value are same. M11 here also, here also, here also. K11, K11 here, K12, K12 both are like this one. This is how it is given. Okay. So this is given, and you have to find out the some values will be given. Okay, and you have to find out what is the natural frequency and the smallest one, and the smaller one, the larger one. So how to find out? Okay. So what we will get from here is basically, you know that in order to find out, you do K minus lambda M, determinant equal to 0, where lambda equal to omega square, right? So you do that. So what do you get? You get K11 minus lambda M11, K12, K12 and K11 minus lambda M11 equal to 0. And what you get? You get simply here K11 minus lambda M11 square minus K12 square is equal to 0. Right? That's what you get. Yeah. Okay. And that really means if you see here K11 minus lambda M11 is equal to, you get plus minus K12 simply, right? And hence you get K11 is equal to lambda equal to, from here we get lambda M11 equal to K11, and then you have minus plus K12, right? That's what you get. Yeah. And lambda equal to K11 plus minus K12 divided by M11. So this is omega n square, and hence omega n equal to root K11 plus minus K12 over M11. Okay. So here you would say that K11 is greater than K12. Yeah. So that the whole thing is positive. Yeah. And hence the omega 1, which is the smallest one, will be K11 minus K12 over M11 root is the answer. You get the smallest one. This is the smallest frequency. The largest frequency will be the plus. If you get omega 2, which is equal to root K11 plus K12 divided by M11. If you have plus here, this is larger. So omega 1 is less than omega 2. Yeah? So you put these values, you will get omega 1 and omega 2. Here omega 1 is the smaller one, omega 2 is the larger one. Yeah. Okay, this method something you have to follow for the multi-degree of freedom system. There are some tutorial problems where you have to do it. Yeah. So and in the lecture also we covered extensively basically how to find out the omega n. Second part was how to find out the eigenvectors, the ratio V2 over V1 and U2 over U1. Yeah. So what we know so far is this problem will be the same kind of problem, and there you will be m will be of the same form, k will be of the same form, and from there we have to find out. Okay, so I asked associated with omega 1, which is the smaller result frequency, what is the eigenvector? Specifically, we are asking that if what is the value of U2 over U1 equal to what? When these are eigenvector. What is the meaning of that? If U1 and U2 are the eigenvector, that really means your k minus lambda 1, yeah, k minus lambda 1 m, and then you have U1 U2 is equal to 0. That is the meaning of this eigenvector, right? This is eigenvector. Okay, so there lambda 1 is root lambda 1. Lambda 1, where lambda 1 is omega 1 square, and omega 1 square is K11 over minus K12 over divided by M11, right? So we put that value and we will find out the actual value of U1 and U2. So put this value here. So we have, what do we have? We have K11 minus, and we have lambda 1. So we can simply put lambda 1 and then M11, then we have K12, K11 minus lambda 1, M11, and multiplied by U1, U2, and that is equal to 0, right? So both equations will give you the Same thing as we discussed during the lecture also. I said both are dependent basically. Yeah, so, and determinant is, that's why determinant is 0, because both are dependent. Yeah, so this row will be a constant times this row, and because of that you get this kind of determinant is 0, which is necessary condition, right? Okay, so what you get from here? You get u1 times k11 minus lambda 1 m11 plus u2 times k12, that is equal to 0, right? So u2 minus u1, if you want to find out this, what do you get? So u2 minus u1 will be equal to simply so here we have, so we get k11 minus lambda 1 m11 divided by k12 will be the 1, right? So k11 lambda 1 m11 multiply k2, so it will be minus of that, so I guess it should be like this one, k minus 1. Yeah. Okay, so you put lambda 1 m1 minus k11, so this comes, so this is the value you get. Okay, now m11, the lambda 1 is this, lambda 1 from here, lambda 1 is what? K11 minus K12 over M11. So say you put here. So that really means M11 multiplied by M11 multiplied by lambda 1 equal to K11 minus K12. Right? So what do you get? You get K11 minus K12 is the value M11 times lambda 1. So M11 times lambda 1 equal to K11 minus K11 from here divided by K12. What do you get? What remains is minus 1. Simply this is minus 1. Answer is minus 1. That's it. Straightforward. Okay, the next problem is V2 over V1 you have to find out. Okay, so the V2 over V1 equal to what? Where V1, V2 are the eigenvalues associated with the second one. So this is V1, this is V2, and this is lambda 2 here. Yeah, so this is lambda 2. So you have the same lambda 2 here, lambda 2 here. This is exactly the same as how we solved earlier. Instead of U1, you have V1, V2 now, V1, V2 equal to 0. And exactly similar expression you get V1 here, you get lambda 2 here, you get V2 here. All other things remains the same, right? So hence V2 over V1 will be equal to lambda 1 minus here lambda 2 it becomes, right? Lambda 2 m1 minus k1 over k12, and lambda 2, if you see here, lambda 2 is a square of this lambda 2. So lambda 2 multiplies by m11 equal to k11 plus k12. So k11 plus k12. Yeah, so k minus k1. So what you get is k12 divided by k12. Now hence the answer will be simply 1 plus 1. So value should be just 1. Yeah. So regardless of what values you get m11 here, k11 or k12, answer will be the same for everybody. Everybody should get v2 over v1 equal to 1. Yeah. So you get that from there. Now for the same matrices M and K, the next question is to find out what is M like xt over x, okay, where x is given. Okay, just a minute. What we are finding out, x1 and x2. So this is x1 and this is x2, where it is saying that these are the two eigenvectors. x1 and x2 are eigenvectors, and this is equal to what? Okay, so we have seen already that they are orthogonal. Orthogonal means if 1 and 2 they are different eigenvectors, then it will be equal to 0. And similarly for k also it will follow the same thing. If we have x2 here and this is x1 t here, yeah, so it doesn't matter which one comes where. If these two are not matching, it will be 0. So one question was on this one, the other question was this one. Very straightforward. Yeah, don't even have to spend some time. Still, lot of students could not get it. Yeah, so and this was covered in the lectures very nicely. I stressed that see here this will be 0, and actually we proved basically not only with the statement but actually the lecture proves that this will be equal to 0. Another problem in which I said that mx1 x1t is given, this is equal to like 1001. So this is given like this one, and then I'm asking you what will be the value of this x1 t, sorry, x1 and x1t is equal to what? Okay, this is given, x1 will be the eigenvector associated with the lower frequency. So x1 will be equal to u1, u2, right? And x2 will be equal to v1 and v2. And we have seen that, right? So in this case, the example will be some constant a multiplied by, this will be 1 minus 1, right? So equal to some other constant b times 1 and 1, because ratio is minus 1 in one case, we have seen that, and ratio is 1 for this case, b1 and b2. b2 over b1 is 1, so we have 1, we have a and b, because of we need some kind of a scaling so that we get that. And what is that scaling? Scaling is we get like this. How do you get? So you have m. Basically here not even we have to actually do all the scaling and all. From the lecture itself you will find out whatever the eigenvector here which is already a scale. So you can see this is a kind of hat that we used in the lectures, right? So if there is any eigenvector which makes it 1001, that really means these eigenvectors are already scaled, and hence this value, since this eigenvalues are scaled already, this value will give you equal to the eigenvalue itself, which by eigenvalue is nothing but omega 1 square. Yeah? And omega 1 square we already got, and the value was what? Value was k11 minus k12 divided by m11 is the value of this one, lambda 1, simply. So this input value you get it. So we derive already lambda 1 omega equal to root k11 minus k12 divided by m11. We got that already. So here it is like this. Similarly, if x2 t m x2 is equal to 1001, and this is the bigger one, okay, omega, this associate this eigenvector, it's given that x2 is associated with the larger natural frequency, which is omega 2, right? So we immediately we know, if we have attended my lecture video, you would immediately know that this is already has to be already scaled, and hence you get identity matrix. And because of that, what you get here? You get this will be nothing but x2t k x2 will be equal to lambda 2, which is equal to omega 2 square. Yeah? And this omega 2 square was nothing but k11 plus k12 over m11. The value will be equal to a square of the natural frequency, simply, nothing else. So this value, this is how you can find out. Yeah. Another question is m and k of the same type, and the C is also given such that this is C equal to A times M plus B times K. Yeah, this also in lecture we have covered, and we shown that the way this is a diagonal, K also can be made diagonal automatically if you have the P matrix, multiply both the sides, called model matrices, and if you multiply same model matrices here, you can also diagonalize this one. Yeah, so finally what the equation we get? So if you see the lecture video, we already see after multiplying the model matrices, we start with like this one, mx double dot plus cx dot plus kx. We have like this, and this is equal to any force F, like this. All are vectors. Just like x, these are vectors. And then we chose x equal to p times y, where p is a model matrix. Yes, okay. And then we multiply pt here, pt the transpose m p, and then we have here y double dot plus ptc p y dot plus ptk p x equal to ptf. This one, now if we choose p to be a scale, means it's a hat. Okay, so this is the hat. Okay, in the lecture video we used hat, which makes this one identity matrix. So becomes I y double dot, and this we find out what is the meaning of that. And this one, sorry, this is, it has to be y here, y like this. This one is lambda. Yeah, so lambda matrix, and this y. Yeah, here this will be the, since C equal to this one, if you put it here, automatically we get A I plus B lambda matrix, right? Like this one is equal to P hat TF, and automatically this is diagonal now. So this has, where this one is nothing, but we have lambda 1 0 0 lambda 2 only. Yeah, where lambda 1 equal to omega 1 square 0 omega 2 square of this form. Yeah, okay. So if it is like this one, automatically we will find out, we will have two independent equations now, as we did in the lecture video. You can watch that. Yeah, so this is basically one equation will be, as I wrote there also, y1 double dot plus 2 zeta omega 1 y1 dot plus we have here omega n, right? So omega 1 square, so omega 1 square y1 equal to some force F1. It will be something like this one, right? So but compare with here identity matrix, so 1 1 is fine, but this value will be equal to this value, right? So, and this is both diagonal. I identity matrix 1 0 0 1, and this gamma, the lambda is also a diagonal matrix, omega 1 square 0 0 omega 2 square. What do you get? You get 2 zeta omega 1 is equal to nothing but equal to this one, means A plus B omega 1 square, and hence zeta equivalent zeta will be equal to A plus B omega 1 square over 2 omega 1. This is the answer, where omega 1 will be, again, if it is specified, omega 1 is the smaller frequency, and that quickly you can also find out. And we have been, if you do same problem again and again, you will realize that omega 1 will be simply root under k11 minus k12 over m11, right? This is omega 1. So this omega 1 value, you put it here, value of A and B, and you will find out the damping ratio. Yeah, this is damping ratio you have to find out for this problem. So this is done automatically. Similarly, you can do for the second one, means for omega 2, right? So what will be the value? Instead of this is zeta 1. This is zeta 1 associated with omega 1, and zeta 2 will be, instead of omega 1, you will have omega 2. That's it. Nothing else. A plus B plus omega 2 square over 2 omega 1 omega 2 will be the equivalent damping ratio associated with omega 2, which is omega 2 is the larger natural frequency. Omega 2, where omega 2 is equal to root k11 plus k12 over m11. So this we did in the class, yeah, in the lecture we did, yeah. Summarize the effective damping ratio. You get first one, this one, second one is this one, where omega 2 is this, where omega 1 is this one. Okay, this is effective damping ratio for a multi-degree of freedom system. Now some problems I asked you directly from the tutorial. Okay, one of the example was in which there is a train and there is a spring attached in between. There is another bogie here, so two cars here and here. The problem we asked a true and false type, saying that one of the natural frequency will be 0. Answer has to be true. Yeah. Again, if I gave you the tutorial problem, this tutorial problem does not ask you directly this one, but if you do the problem, automatically you get 1 omega equal to 0. Automatically you get that, and then you should then not only there, even if you have not done that problem in tutorial you have not done, and you are doing this problem, when you solve it, automatically you get omega equal to 0. So you cannot go wrong in this one, you know. So even if the tutorial problem does not ask you this whether 1 omega equal to 0, if you solve it, you will get it, and then you will know. Okay, so then how to know? So this is M1, let us say both same M, right? So both have M here, both M here, and then it has K. Okay, so how do you formulate? You formulate for first one, let us say this is moving and this is stationary, so this will pull this way, and how much pull this will be, let us say this is x1, this is x2. Yeah, so how much it will pull? It will be k times x2 minus x1, by which it will pull this way. This is m. Yeah. So then what do you get? Even if this one is m1 is different, this is mass different, this is different, doesn't matter. Then also you can do. But in this case, it is given that both are same. So what is the equation? The equation will be simply k x2 minus x1 equal to m x1 double dot. Hence you get m x1 double dot plus k x1 minus k x2 equal to 0. This is one equation. Yeah? Simply you do for this one, and you have like this one. Right? So x2 this way. Now still you can assume this x2 is more than x1, right? So if that is the you can assume this a little bit slower or stationary, so this is more, there will be a stretch will be this way, so it will be k x2 minus x1, right? So and this is m, so equation will be simply m x2 double dot equal to minus k x2 minus x1, right? And hence you get second equation m x2 double dot plus k x2 minus k x1 equal to 0. Yeah, so this is the equation you get. Now you have in the matrix form, you get m 0 0 m, and then you have x1 double dot x2 double dot plus k here k, and then you get minus k k, yeah, and then you have x1 x2 equal to 0, right? So here equal to 0. Now if you see the determinant, you can also guess lambda 1 lambda will be 0, because a stiffness matrix K is determinant is 0 in this case. Okay, that really means if lambda is equal to 0, then multiply by m1 will also will make it 0, and this matrix minus 0 matrix will be the, in that case, the whole matrix. What I mean to say is that if you have the determinant of estimation matrix equal to 0, automatically one of the eigenvalues will be 0. Yeah, even that I did not tell in the lecture, but this you can see here also. You know, automatically you will find that it will be the case. Okay, so what is the eigenvalue problem? Eigenvalue problem in this case is k minus lambda m 0 minus k. Okay. So I'm taking the determinant directly. So k minus lambda m, this is minus k minus lambda m will be equal to 0, right? So we will find out lambda. What do we get? We get k minus lambda m square minus k square equal to 0. And what do we get? We get simply like this here. Okay, so from this we get like this. So k square plus 2 lambda m 2 lambda mk, it will be minus and then plus lambda square m square minus k square equal to 0. Yeah, and that will give you this, and this cancels out. You have lambda square m square minus equal to 2 lambda, or write like this, minus 2 lambda mk equal to 0. Lambda becomes common, or lambda m square minus m is common, so it can go away. So lambda m minus 2 lambda, 2 lambda is outside, m is also gone, 2k is equal to 0. What you get? Lambda equal to 0. That really means omega n square equal to 0, or omega 1 equal to 0, right? That means one of the omega will be 0, right? So it tells you automatically. And the second one, this is lambda 1. Lambda 1 was this. Lambda 2 will be lambda 2 equal to 2k over m, right? Or you can also find out omega 2 equal to root 2k, it will be 2k over n. Yeah, sure. Root 2k over m. Yeah, correct. So root 2k over m will be omega 2. But what you get here is omega 1, which we were looking for. Omega will be 0. Yeah, so hence you get the. So this equation, this problem was given. But if you solve it, you cannot go without getting 1 omega equal to 0. That's what I wanted to test, whether you are doing the tutorial problems. Yeah. Again, another problem that I gave from the tutorial was the car problem, right? So this is the, okay, so here there's a wheel, but again here this is a spring here, and the mass, equivalent mass is like this one. And instead of saying that the stiffnesses are different, we say this is the same k both the sides, and mass is m, and the center of mass is exactly in the middle. Yeah, so what we are saying, this L1, this is L2, I am saying L1 plus L2 equal to big L over 2. That's what it is given. And then I asked what will be the natural frequency of the just the vertical vibration. Okay. And if you consider just vertical vibration, you can just see in this case, basically when you have L1 plus L1 equal to L2 equal to big L over 2 and both are K same and this is exactly in the middle, you will see that the two modes are entirely independent. If you write the equation, you will automatically get the equations which are not dependent on each other. Yeah, so you will get diagonal matrices automatically. You will get. In any case, just looking at it, you can have you can directly write omega n equal to total k is this 2k divided by m. Simply, you can write like this one. Yeah, or you can also write the equation from there. Also, you can do. And how do you do? See, it goes by x. Let us say, and then you have a kx here. Kx here, and here what do you find? You find m, and then x is upwards, mx equal to minus kx and minus kx, right? So simply you get mx double dot plus 2kx equal to 0. Simply you get like that. Do you get any moment here? There is no moment. If you see a moment is automatically, if you take moment from here, both is balanced automatically. Hence, the second mode is not interfering here. The moment is not coming here because there is no torque produced, and hence this mode of vibration will go on. It will never go this way, you know. So typical vibration will be the both of them together, but it is also possible that it's purely vibrating upward only, and hence from here the equation is given like this one. You can guess that omega n equal to 2k over m. Very simple. Yeah. Second thing we asked is for rotational, purely rotational vibration, what will be the omega, right? And how do you find out? Okay, so you assume this is not moving. Yeah, so simply this is like this one. Yeah, so and that means this one will be a stretch. Okay, and by how much? This will be a stretch by if we from here to here is L over 2. So by if it is theta, L over 2 times theta will be a stretch upward, and here it will go downward. How much? L over 2 times theta. Okay, so the torque which will apply here, the force here by which this is going to pull down will be K times L over 2 times theta, and similarly here by which it is going to push up because it will come down, so it will push up, which will be K times L over 2 times theta. So these are only forces which are acting. Okay, you can see here that vertical, there is total force is automatically equal to 0. So K L over 2 down upward, here downward, automatically both are equal to 0. Hence the vertical vibration is not going to appear here. So there will be a purely rotational motion in this case. Yeah. So then next is the writing the equation. And how will you do? Okay, so you have to write the torque. What is the torque? So torque is this is clockwise about this one. So minus K L over 2 theta times L over 2 for this one. Same value here. L same value here. So just multiplied by 2. Yeah, and then equal to, you write equal to J, right? And this is J, and which I said equal to 1 by 12. What I wrote was m over 12. Yeah, so J is 1 over 12 m L square times theta double dot. Yeah, that's what that is. The equation becomes 1 by 12 m L square theta double dot plus, in this case, what do you get? You get K then L square over 2 theta equal to 0. This is what the final equation you get. And hence this is let's say this is m dash and this is k dash. Yeah, and hence omega in this case rotational, right? So I write omega r, but nothing but k dash over m dash, and what you get is k L square over 2, and then you have 1 over 12 m L square. Yeah, and then you get L square cancels out, you get 6k over 6k over m. So the value will be like this one. Yeah. So for purely rotational, root 6k over m. For vertical, root 2k over m. You put the value of k and m, you get the values for both the things. So another tutorial problem, and where there is a spring goes like this one, and then there is a aerofoil. Okay, this rotational spring here as well, and this is the center of mass G here. Yeah, and J naught is the second mass moment of inertia, and mass is m. This is small k, this is the big K, is the rotational spring constant. Okay, and given eccentricity which is equal to U. Okay, this problem was in your tutorial. Okay, it was a matching problem, even matching problem in which there is no chances of any error, no chances of sign error, no chances of any mistake if you have actually done it sufficient times. So, and on top of that, I solved during the live session. Okay, so at the end only one student was remaining, all other had gone, but still I solved this one. Yeah, so if you had attended, they would come very easy. You can actually do very fast basically. So the idea here is to find out the stiffness matrix, given that what I said if the mass matrix is M0, 0, J naught, then what is the stiffness matrix? If M equal to this, then the stiffness matrix equal to what? That's what I asked. And this is a matching problem. Okay, now to do that, what are you going to do? Now, you will assume that this point G has moved up. So there will be two things. So one will be moving up. So from this point has moved up by, let us say, x, and this also has rotated by the same point. Yeah. So look at the spring here. Yeah. Okay. So what happens for a spring? If it is moved up x and also has rotation also by theta, there are two things are there. So for the spring, there will be two kinds of displacement here. One will be this. So earlier it was here. So and then it has gone up. So there will be x associated with this one. So the displacement will be x because this has gone, the whole thing has gone up, this center of mass has gone up. Then there is rotation with respect to G. So rotation will be plus you have E times theta will be other displacement. Okay. So this one has, this is equal to 1, it has gone up, something like this one, which is equal to x. And then about this one it has rotated, and from here it has become here. So from here to here, this is E times theta. So there are two of them. Okay, now rest is, once we know the forces, so the force here will be accordingly the two forces. You have K here, and then you will have x plus E times theta will be the force which is downward. Again, this is rotational spring as well. So because of that, since it has gone anti-clockwise, so there will be a clockwise K times theta moment as well. So there are two forces acting. One is acting here on this spring, which is K times x plus E times theta, and then there is a clockwise because of the rotational spring. Okay, now the equation. How do you write the equation? Equation is basically the vertical vibration first. Then what do you get? The total force here is K. which is downward. So minus kx plus e theta is the vertical for this one, plus this is the force, will be equal to mx double dot, and hence you get mx double dot plus kx plus ke theta equal to 0. Yeah. So right there, you know that if m is here, so automatically k is here, right? So you have k1, you automatically you get here, this will be nothing but k11, this gives you k12, automatically there, and always k12 will be equal to k21 automatically, so you can also go from there. So anyway, two values you get here, so at least two values from one equation you can get it. Okay, next equation is the clockwise the force that you are getting is the total moment has to be equal to 0. Okay, so which all things are acting here? One thing is acting is the clockwise k theta. So you have big k theta is a clockwise, which is minus because clockwise. This k is also clockwise, k times x times also minus k times x plus e theta multiplied by e, because this force is acting here, and multiplied by this lever e is the moment, is also clockwise, right? It's gone clockwise. So this is equal to, you get j naught theta double dot, and hence what you get is j naught theta double dot plus k theta. From here you get plus k e square theta and plus k ex is equal to 0. Now this one and this one you can write together as you are writing here, so it will be m0 0 j naught, you get x double dot theta double dot plus, and from here you get k, and then you get ke, and then you get here also in this you get ke again for x1, and then you get big K small k square. Okay, so x theta. So value are this one. Yeah. So simply value will be k11 equal to a small k, k12 equal to k21 equal to a small ke, and k22 equal to big K plus small k e square. Yeah. Again, it was in live session actually. Yeah, and you had the tutorial problem as well. Yeah, and if you are making mistake, you are not getting this one, I don't know what to say. Other problems from these chapters are also from your book only. Yeah. So for example, one of the problem is this is k 3m, and then like this one 3m m, then 3k. Like this one. Okay, this is problem in the book also. You can find out the first problem. Yeah, so m. This is 5.1 in the book. So the problem is the mass matrix is 3m 0 0 m. Yeah. Then k equal to what? So this like this. Yeah. So you can so k like this one. Yeah. Okay. Now you can have here x1, here x2, and you can write equation here in terms of how do you write? You will write. Let us say this you can assume x2 is not moving, only x1 is moving, right? So what do you get? 3m. And since this one is only this one is moving, this you can assume equal to 0, and hence this will go this side, and you will get compressed. Compressed by what? Compressed by, you get k times x1 minus x2 will be the compression, which will be this side. Okay. Now here, since this is fixed here, so go here, there will be a stretch, and a stretch will be equal to the k times. So you go like this one, there will be a stretching, k times x1 will be the stretch. Hence the equation will be 3m x1 double dot equal to minus k x1 minus k x1 minus x2, and hence you will get 3m x1 double dot plus 2k x1, right? And then minus plus minus, you get minus k x2 equal to 0. So you get the first equation, right? Similarly you can get for this one, if assume x2 is moving, x1 is not moving, for example, right? So that way there will be compression, the back side, which will go like this one. The equation will be 3k x2, yeah, because this is fixed, so move like this one, the compression, so force will act like this one, right? For if we assuming x1 is 0, assume like that, or x1 is less than x2, and in that case, what happens? If it goes like this one, and this is going to a stretch. Since this is stretch, this will go backward. Backward, how much they will be? K. And this one, since this is 0, so it will be k x2 minus x1. Okay? And this is m. So equation will be 3k minus 3k x2 minus k x2 minus x1 equal to m x2 double dot. And hence you get m x2 double dot plus 314 4 k x2 minus and then you have minus k x1 is equal to 0. Okay, you both of them, if you write together, you get k equal to nothing but you get 2k minus k and 4k here, right? This is what you will get. Yeah. So that final equation will be m times x1 x2 double dot plus k x1 x2 equal to 0 0 because of that. Okay, so this is what the equation will be, and this was a matching problem. Okay, so you had to so of course the in the question paper, so there was a typo in the actually the answer key. So instead of 4k it was 3k, hence you were wrongly marked incorrect, but I given you marks for this. I have corrected this to I could not correct basically, but I have given you extra mark 0.25 whenever you have done this correctly. Earlier, if you had done 3k and you had got credit, then you would not get any marks for that. You know, so if the wrong answer, you will get credit only when the k22 is equal to 4k. This question is again from your book only, so see this one. Okay, so basically here this was 5.28 from the paperback. So you have a system where you have k1, the m1, this is x1, then the m2 here, like this one, x2, and there is a force here given here, F1 equal to F0 sine omega t. And then I'm asking you the frequency of this one, M2, the x2, the x2, the frequency of x2 basically I'm asking. Okay, so basically automatically whatever the omega here, the same omega will come here. So x2 will be also will have will be function of omega only. So if this is sine, this also will be sine omega t, plus there will be something phi or something there. Yeah, so this omega t, this omega both will match. And how do you get? In the solution itself, and we have seen that for even for the force vibration, the final the frequency is equal to the frequency of the force itself. Yeah, so in 1 degree of freedom system also we have seen. So here also, while solving this, we assume the same frequency, and actually the solution, if you have the same frequency, then only it actually solves, otherwise the equation is not satisfied. Hence the solution will be omega only. So simply this will be simply equal to this omega. So we are done with chapter 5 and 6 with multi degree of freedom. From chapter 4, transient vibration. So one problem was given the impulse. So giving the impulse F naught, which is the actual area of that. If you see, it is given in Newton second basically. So and this is short impulse, and I'm asking what is the velocity immediately after the application of the impulse for the spring mass system, right? So like this one. So again during the derivation only, in the lecture also, in your book also, so it is given that impulse is equal to, so the total force which is going to be applied here, the integration of that, so so basically the is equal to impulse, right? So F naught has the force multiplied by the time, right? And Newton's second law also says m dv over dt equal to force, right? So this is the equal to force, or simply m dv equal to f dt, and this is nothing but the F naught, right? And hence dv is the velocity F naught over m. Initial velocity, initially it is at rest, so hence this is the final velocity. So velocity which is gained, the velocity just after application of the force will be F naught over m. This is v equal to F naught over m, right? So this is what the answer is. Another question is where there is a spring and there is a mass here, and then it says the suddenly constant force F naught is applied here, and then it is asking the maximum displacement x max equal to what, and velocity max equal to what. That's what it is asking. Yeah. So there are two questions basically. So what will be the question? So basically this the solution actually we have done in the lecture. Basically the xt will be equal to F naught over k. We have seen that, and 1 minus cos omega nt, right? So omega nt. So that if you have t equal to 0, you have 1 minus 1, and you get x equal to 0. So this is the expression that we have done in the class actually, yeah? for a step input, yeah, with F naught. I actually wrote in F naught like this one. So this is the one we derived in the class itself, and it makes sense how we did it. Even I also plotted it, and it went like this one also, right? So it will go like this. If you plot like this, go like this one. From here to here, this is F naught over k, and here also F naught over k, right? So maximum displacement you can do from here. Maximum will be when this is 2. Maximum of this will be when this becomes 1 minus 1. So x max equal to 2 F naught over k is the answer, right? So this is the answer. Now velocity x dot t equal to, you can get from here F naught over k, and then 0, and then minus plus, you get sine omega nt here multiplied by omega n, right? So you get F naught omega n over k is the velocity into sine omega nt, right? So velocity max equal to whatever you get here is the maximum value, right? So this value, because this sign goes from +1 to -1, so this is the maximum value, will be f naught omega n over k, where f naught over k and omega n is nothing but k over root k over m only. So what do you get? You get f naught over root km simply, right? So this will be the answer. So this is done, this is done. Hence the only 3 questions were from the transient vibration problems. All other problems, rest of the problems were actually taken from the quiz number 1, actually, all other. In that also there was one question that nobody attempted, not attempted, they tried but answer was not correct. Okay. So solution to quiz 2 problems I will post tomorrow. So the rest of the problems were actually directly copied from quiz 2, yeah, and which had I think 9 or 10 problems were from quiz 2, sorry, not quiz 2 but quiz 1, the first quiz, and so for all the 25 questions, okay, I will post solution tomorrow. Okay, so today was only about 25 problems which were the new problems which were from chapters 4, 5, 6, 7. Okay, so the others, the quiz 1 were from chapters 2 and 3 only. So problems from chapters 2 and 3 I will make video tomorrow and I will send you. Okay, that is all for now.